All right. Okay, we're recording and we are sharing. So life is good. Welcome to week 2 of ILM220. What is it? Oh, ITM220. They changed that. For those of you who aren't aware, they changed the course number this semester, so it's taken a minute to get used to that. I'm still Brother Stevick. I'm still teaching the class. Week 2. All right. Everyone have a good week 1. Any questions from week 1? Anything, any unresolved issues?
I think we're all good.
Excellent.
I have maybe a question. Okay, so it was about the command line.
Yep.
I had misspelled a word and tried to go back, and I could not go back. Was that just an error on my end?
What do you do what now?
I was trying to. I had misspelled a word,
Uh-huh.
so I tried to go back to fix it, and I
Yeah, you can't
couldn't
do that.
get. You
You have to
can't.
retype the entire thing.
Okay, okay. Thank you.
Yeah. Yeah, the whole command line experience is I don't know if I got into this last week, and since everyone's answered the question at this point in time, I can give my opinion. The command line is for when you want to show off. Because it's just you can't go back and change things. You have to rewrite the entire thing. You have to know exact coding that doesn't give you any error warning. There's no insta there's no autofill with the text. It's a pain. So no, you didn't do anything wrong, Ann. That's just you have to go back and rewrite the entire thing. Any other questions for week 1? There shouldn't be a whole lot. There wasn't a whole lot to do. All right, then let us talk week 2. Today we're going to talk about a couple things. We're going to talk about these clauses here. We're going to talk about the mechanics of a SQL query and the SQL clauses. And I'm going to give you a brief idea of what an ERD is and what it looks like. And we're going to use these different comparison operators. We can get all to that stuff. We're not going to talk about null values tonight. I don't think it's on any of your quizzes. If it is, the answer is pretty obvious. So I'm not going to get into null values. It's null is a whole 35-minute conversation on its own. And then we're going to talk about reverse engineering a website and what that means and why you shouldn't be afraid of it. All right. If there are no questions, I'm going to go ahead and begin. And I'm going to bring up this. So we talked about last week, we talked briefly about what a relational database is. A relational database is when you have this logical structure of data on your computer, and it's separated into these things called tables. And a table is a logical object within a database that contains data specific to the name of the table. Okay, so here, this is an ERD that I built a couple of years ago. One of the students was doing a final project on the space program to track launches. So we kind of played with this, and I kept this. So here I've got a table called astronauts. Okay, and right off the bat, I've been incorrect. So it should be astronaut. We don't pluralize tables. That is not okay. So we've got a table called astronauts, and in there, I've only got last name because I was doing a demo on it. But in there would only be information about the astronaut: name, address, phone number, rank, things along those lines. Things that could only be identified, used to identify that one person. I have here, I have a table called destination. I have a table here called spacecraft. So these will only hold the information based on these people, based on here, okay? Now, we have all these other little tables here. We have missions, okay? And we've got these little lines here. Now, these lines are what we refer to as foreign keys or joins. These are how the tables are joined, okay? So this is what we mean by, we're going to get into this in a lot more depth in the coming weeks. But this is just to show you what an ERD looks like and kind of how it functions, how the data flows across this, right? So, and when you click here, you see these are where the database are connection, right? In this ERD, it tells you a lot of stuff, okay? So here you go. Okay, it's better. All right. Like it better. Good, 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 good. Okay. So you have these logical structures called tables. In there contains the data relevant to the title of that table, but we need to have that data accessible to other tables and to the customer so we can put that information together. So when you look at this ERD, we've got an astronauts table, we've got a spacecraft table, we've got a destinations table, we've got a launch locations table, and we've got a class table, right? So because of the way this is situated here, we have astronaut and we've got missions. Now, when we're looking at joining tables through the normalization of data, we have to make sure that whatever relationship we do between the two tables is what we call either a one-on-one or a one-to-many. Okay? There's three kinds of relationships. There's one-to-one, one-to-many, and many-to-many. One-to-one means one value here equals one value here. One-to-many means one value here can equal many rows here, and one row here can equal many rows here. Many means many rows here can equal many rows here. We do not allow many-to-many connections on databases. Many-to-many, I don't even, it's theoretic to do them, but it's a giant nightmare, so we don't do it. We only do one-to-many. So for example here, I've got a table called astronaut and I've got a table called missions. One astronaut can go on many missions. One mission can have many astronauts. If I connected these two together, it would be a many-to-many relationship. I can't have that. So I created a table between the two of them called mission astronauts. And so here, one astronaut can be on many missions. One mission can have many astronauts, and it's in this table, not these. Okay. So we have a one-to-many relationship here. One-to-many, one-to-many. These two together have many-to-many. We don't do that. A mission can only have one launch site. So this is a one-to-one relationship. A mission can only have one destination. It's a one-to-one relationship. A mission only has one spacecraft. It's a one-to-one relationship. Okay, so that's why these connect directly to here. Now, the way this data flows, right, because all these tables are connected, I can say what astronaut has been to what destination. Because astronaut goes from mission astronauts to missions to destination. Because I've got this connection, I can write a query that tells me what astronauts have been to what destination. I can tell what astronauts have flown on what spacecraft, what spacecrafts have what destination. Just because they're not directly connected doesn't mean I can't access the data through them. Again, very, very high level topic. We're going to get to some select queries in a second so you can see how this works. But does everyone kind of get the general idea on how data flows across the table?
Yes, sir.
Okay. All right. So now the cool thing about this, I'll show you this trick here. So if you do the final project, you have to turn this into me. You have to make a database and show me the ERD. You also need to give me the code to create the database. If you go here, if you have this ERD design, and we'll design, starting next week, we'll start designing ERDs. If we go here to database, and I go to forward engineer, this will create the script for me to build the database. So those of you who are thinking about doing the final exam, the final project, keep this in mind because you'll be needing this. All right. Moving on to queries. Okay. So last week we had talked about the fact that T-SQL is English. It's a very, very simple way of programming because the words make sense. Last week we talked about DML, DML languages, DML code. That's data manipulation language. That includes the 4 commands: select, insert, update, delete, and truncate. There's a 5th one, but truncate's different. We'll talk about that later. Okay. Today we're only talking about select. You'll hear me refer to them as clauses. Okay. The select clause, the from clause, the where clause, the order by clause. It's because they are clauses. They all have connections. They all have requirements to be there. Okay. The select clause tells me what columns to look at in the table I'm querying from. The from clause tells me what table I'm querying from. The where clause tells me how to filter that data. And the order by clause tells me how to put, what order to put that in. Okay. If I do not have an order by clause, it orders by default by the primary key. The primary key is the column that the table is organized by. The table's organized by the primary ones, the organized by, right? You get to choose that. If you make the choice of not having a primary key, the database doesn't like that, and it will assign a primary key to it. Don't let the computer assign the primary key. Always have a primary key assigned to your tables. And when we start building databases, we'll talk about that. Okay, so just a couple quick things about Workbench for this year. If it's blue, it means it's a command. If it's yellow, it means it's a text field. If it's gray, it means it's a function. And there's one other. If it's light blue, it means it's commented out. Now, you can change all these colors if you want to your settings. Feel free to do that. Customize the environment however you like. But that's just the way to tell the difference between that. Blue is a function. Yellow is a string. And then light gray is a function. And now anything that's just in solid like that, the query assumes it's either a column or a table based on where it is. If it's in select, where, or order by, it assumes it's a column, unless there's quotes around it. If it's in from, it thinks it's a table. Okay. The first clause, we will always have to use the use clause. This tells the query what database to use. If you look over here on the side, I've got 1, 2, 3, 4, 5, 6 databases. If I do not run this, it's not going to know which one of these to use. So you always start with this use clause. I'm using this to kill a database. Next query is very simple. Again, select from. Select the column's last name and first name from customer. If you go over here to customer and click this little arrow, it shows you the columns. So I just want these two on last name and first name. So I'm going to run this, and I'm going to get my results. And these are just the order in which they've been entered into the table. They're going by the primary key, which is customer ID. So Mary Smith was the first customer, Patricia Johnson was second, so on and so forth. And it returns it into 2 columns, last name and first name. Now you notice that the title of this column is last name, and the title of this column is first name. The query will always title the column by what you have here. I'm going to show you what I mean in a second. So I've got another command here. It's the same command. So I did a couple of different things. Here, I select last name, first name, but I've got this comma, single quote, comma, close quote. So whenever we define a string in a query, we use single quotes. We don't use double quotes because double quotes mean something else. Okay. So what I'm saying here is I'm saying select last name and first name, but I want you to do something different this time. I want you to concatenate it. And what concatenate means, it means take two strings, two or more strings, and put them together into one result. So I'm concatenating the last name and the first name, and in between the two, I'm putting a comma and a space. I'm still taking it from the customer table, but now I added this order by clause, and now it's going to order by customer. That's not going to work because I took away that customer, so I'm going to do different here, okay? So let me do this. And here we go. I've got Mary, Patricia, Belinda, all these people, right? Okay. Now, next thing I'm going to talk about here is notice the name of the column. It's concat last name, first name. This doesn't make any sense. We don't want people to see that. We want the last name. We want that to have the column to actually have a name. Okay. So what we can use is something called the as clause, which is here. So if I do select concat last name, first name as customer, when I run this query, that column is now called customer. Everyone with me? Just do like a little icon or like an applause thing or something. There you go. Ah, thumbs up. Love it. Love it. All right. If I go too fast or say something you don't get, please stop me. I will explain everything. I love this stuff. Okay, so here. Now I have this order by column. Okay. Call it clause. I'm selecting the same thing, but now I'm saying it order by customer. Now, there is no customer column here, but I named this column customer. So it's going to order by this, and it's going to do alphabetically A to Z. Okay. If I want to do reversed, I just put descending. If I want to do it right ways, it's ASC. By default, it ascends. So you don't have to do ASC there normally. If you want reverse, you got to put DSC, DESC. All right. Let's have more fun. Still selecting from the customer table. I'm now selecting the store ID. I'm concatenating the name and setting it as customer. And I'm doing it from customer, and I'm ordering it by last name as opposed by customer. That's going to work just fine. Now I've got a store ID and I've got the customer name. I can order by first name if I wanted to. I don't know why I would do that, but you can. If you hadn't noticed, each next query builds a little bit on the one just before it. So here I have my concatenation of my strings. I've got my store ID from the customer and I'm ordering by last name. Now let's add another caveat to this. I'm going to do the same thing, store ID and the concatenation of the customer name from customer, but now I'm ordering by store ID and then ordering by last name. So you'll see that there's store ID 1 and 2, 1 and 2. So what I'll do is I'll do store ID. So it's going to order everything by that first and then order by last name descending. So I do this. I now have 1 Cynthia Young, and I go down here where the 2 start. And then we're there. Okay. Everyone good with select from and order by? All right. Sweet. Let's add where to the conversation. Select tells me what columns to do and how to make them look. From tells me what table from. Order by tells me the order, and where is my filter. Where tells me how to filter the data to get exactly what I want. Select store ID, concat last name, first name as customer from customer, where last name equals Miller, and I'm ordering by store ID and last name. I went from this, where I had, let's put you up here, where I had 599 rows with all the names, to one row return because I limited it to Miller. Now, this is, I only want where the last name equals Miller. If it doesn't equal Miller, it's not going to show me. If I change this to Mill, I got nothing because there's no Mills. There's just one Miller. Okay. Select store ID, first name is customer. From customer, where last name in. And now I have a subquery. A subquery is a query that you write that is within. So, okay. Back up 1 second. That, what I've highlighted, is referred to as a transaction. Every time you run a query against a database, the correct terminology for it is transaction. Okay. When I put a subquery in here, I have a sub-transaction, which means I'm running this select query, but I'm also running this select query. This select query runs first because it's got to get the values. So this knows what the where clause is going to be. Now, this is a very silly one because this is just where last name is equal to two last names. I just did it to prove a point here, right? So when I run this, it's going to show me where last names are equal to the results of this query. And the results of this query are going to be, let me change this a little bit to make a, I'll just keep it this way for right now. It's fine. I didn't like that because I get the last parenthesis in there. So if I run this little subquery here, this is from the actor table. Okay. So I'm coming from a different table. So I'm running this subquery from a different table. I want to get something that's going to be here. Last name. Let me change this. So if I run this one, okay, parentheses here. Oh, that's right. Okay. So if I run this query now, I got 6 results here, 7 results here. Okay. So I'll get to here. So what I'm doing here is I'm running this subquery. And I'm saying, show me the results where last name is in these results. Now, the in command is not the equals command. The equals command says it must be this. The in command says, as long as it's within this range, I want to see it. So when I run this, anything that's Ackroyd, Allen, or Astaire is going to come up. Now, I also threw this at you here. I threw this like command, right? So like means if it starts with an A. So here I've got A and percentage. That's my wildcard operator. So what this is saying, show me every last name from the actual table where the last name starts with an A. Okay. So when I run this, it's going to show me every customer that has one of these last names. And there's only one. There's Shirley Allen. Okay. Now, for every action, there is an equal to opposite reaction. Whenever we have an in, we can throw the word not in front of it. Not in. So this query is going to say, show me everything that's not in this result set. So it's going to be everything but those three names. Okay. Notice it's 598 because there's only one row missing. I can go here and say not like. So if I run this query on its own, it's going to show me everything that doesn't start with an A. And then if I run this, I get that. So with our where clauses, which is our filter, we can either do equal, which means show me exactly, and this is not equal. Okay. So we're talking about our quality operators here. We have equals means show me exactly what's there. Show me, we have in that shows me what's in this range. And we have like that shows me what looks like this. Another example of in, show me the store ID and the concatenation of the last name. Where last name in Miller Smith. Now, the difference between these two, okay? This is what we refer to as dynamic. This is static, okay? This query will always look for Miller and Smith. It will never look for anything else. This query will look for whatever is in the table that matches this criteria. This will evolve with the increase or decrease of data in the table actors. This will never change. Does that make sense? Dynamic versus static? All right. Excellent. Again, here's another example of the like clause. Show me all this stuff where last name is like D. Okay. Shows me starts with a D. Now, show me everywhere the last name ends with a D. Show me every last name with a D in it somewhere. Show me let me see. Show me a name. Everything that has, I don't care what it starts with. I want an L in it. I want two spaces, and I want an A, and then I don't care what's after it. So my wildcards here, percent means whatever's before it, I don't care. The percent here means what after it, I don't care. All I know is that there's an L followed by two spaces and then an A. I don't know why that one showed up. Oh, that's why it's there. See, because here's L space space A, L space space A, L space space A, L space space A. This is the first letter. I don't care. That's fine, because this means 0 or 1,000 places before it. What I'm showing you here is that there's a lot of granularity that you can do in these where clauses. You can get it down to like, very specific things. And again, this, even though it's a like clause, it is still static because this will never change. Unless you've got a subquery here, this is static. Now here, I've got this one. Select title and description. We're changing tables from the film table, okay? Where description is like percent docu percent, or description like %cow %. So what this is saying here is show me everything from the film table, the title and description. And I want to know if this title has that in it or it has that in it, which means it only has to meet one of the two criteria, not both. If it has docu in it or it has cow in it, it's solid. Show it to me. And I do this. And this is what I got. Here's docu. Where's cow? Cow, 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 cow. Documentary refers to being a lumberjack who must chase a monkey in a shark tank. Oh, it doesn't have both of them. Fast-paced documentary. There's a mad cow. No documentary. There's cow. There's docu. There's cow and documentary. Okay. If we're in the where clause and we have an or here, and we have multiple parameters for the where clause, if the or clause is used, it's either. It doesn't have to be both. If I use the and clause, so here 167 rows turned, the only difference between this one and this one is the or and. So this one's or and this one's and. So that means this one both has to have this and this in it. It can't be either or. I've got to have both. So when I run this, we're down to 93 rows returned. Documentary, there should be cow in here somewhere. Why is that? I don't know where the cow is, but yeah, so it dropped down.
I think it says
Okay.
not like cow.
What's that?
It says not like cow.
Oh yeah,
So
no,
is
sorry,
that
that's right.
dropping it out?
Thank you. That's right. So like that. I meant that. Thank you for catch. Nice catch. Thank you. So here we go. There we are. And as you pointed out, if I put not here, it still meets the two criteria, but it shows me where all the it's not cow. So here I have 8 rows returned, and if I do this, I have the 93. Last thing here is this one here. Again, I'm just getting store ID, last name, but here I have this order by, and I have 1 and 2. This is back in the 60s, the 1960s, how they would code, and 70s. Order by 1 and 2 means order by the first column, then the second column. Because I don't know, they didn't want to be bothered to type out the names of the columns. But that's all that means is I think there is a question on your quiz about this, 1 and 2. So 1 means store ID, 2 means customer. Okay. Everyone good? Excellent. All right. Now, I keep referring to the database as an engine, and there's a reason for that. When you have MySQL or Oracle or SQL Server or MariaDB or MongoDB or Hadoop or whatever running machine, it's constantly running. It's not like a program. It's not like Excel, or it's not like Word. Okay. Those are only running when you turn them on. The engine is always running behind the scenes. Okay. And when you put this code into the engine, it doesn't understand that. It changes it from T-SQL to machine code. Okay. And it does not execute it in this order. It does not do select from, where, order by. Does anyone want to guess, of these 4 queries, when I send this to the engine, which one runs first?
It's from, right? Is it
Matthew,
from?
did you say from?
Yeah.
That's absolutely correct. The from works first. Any idea why the from works first?
Because it needs to know the table first.
What's that?
Needs to know the table first.
Yes. So and that's exactly it. So what happens is your data is stored on the hard drive, right? The engine can do nothing with anything on the hard drive. The hard drive is just sitting there. If you've got a book on your bookshelf Can you read it? No, you got to take it off the bookshelf, right? So in order for the query to do anything with the data, it's got to pull it off the hard drive. So this command tells the engine, go to the customer table, get all the data that's there, and put it in RAM. Because RAM is where you can do things. You cannot do anything in the hard drive. The hard drive is permanent. It's static. It can't change. RAM can. Does that make sense? So the first thing that happens is it says, go get this data. The next thing that happens is the where clause. From where? Because we want to filter it out before we're done. Because, and the reason why the where runs before select is because the column that's in the where clause doesn't have to be in the select clause. I can do where, I don't have anything, but like I can change from where active is something, right? Okay. So the column in the where clause does not have to be in the select clause, because what happens is with each layer of query that clause that it runs, it eliminates data from RAM. So if this ran first, it might get rid of the column that's doing the whereby. From gets data, where clause gets rid of anything that doesn't match that, and then the select clause happens, and it gets rid of all the columns that don't need to be there, and then it orders it. Order by always happens last. From, where, select, order by. Okay. Moving on to the next topic. I said this concat is a way for text columns or text items to merge into one. Okay. When I do this, I don't have to do anything special through the rest of the query. I can just do that and it'll work just fine. Okay. It's a text concatenation. When I do this with numbers, it's called an aggregation. Okay. So here I've got this. From the film table, I'm selecting the rating column, and I've got this function called count. And what that function does, it returns the number of rows that has that the rating column has. Okay. Now, this is an aggregate function. It's not very aggregating here, but we'll do ones that are far more fun later, right? So this is an aggregate. I'm selecting rating and then the count of how many ratings there are. So what happens here is I've got, let me just do this here. Let me show you this. So I'm just going to select rating from film. PGG, NC-17, so on and so forth, right? I've got over 1,000 rows returned with ratings. When I run this query, it's going to give me the rating and how many times each rating shows up. It's aggregating the ratings. There are 178 G movies, 193 PG through, so on and so forth, right? Now, I'm going to say this 1,000 times from now and the end of the query. If you use an aggregate function in your select query, you must use a group by clause. The group by clause houses any column that is not being aggregated. If I run this without the group by clause, I get an error. Okay, so I must have this aggregate in here. This group by. Okay. Jumping over to here, I've got another query. There's another simple query here. I've got rating and I've got length from film, rating length from film, where the length is between 45 and 100. So I can do ranges in my where clauses. So this will show me where 45, between 45 and 100. Okay. Now, here I have select rating, and instead of max, or instead of count, I've got average. So show me the rating and then the average length of the film. So what it's going to do is it aggregates every rating, the length of it, and gives me the average of them. From fill, group by rating, order by rating. If I run this, okay, it gives me that, right? Now, if I want to do a where clause on average length, I cannot use where. I cannot filter using where, because where is for static values. It's not for aggregate values. I must use a command called having. Okay. I must use a command called having. So here, select rating, average length, blah, 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 having average length over 115. If I do where, I'm already going to get an error. It has to be having. Okay. Last query of the night. I've got my average. I got my function here. Here I've got select rating, the maximum replacement clause, and the minimum replacement clause by rating with a group by. This just shows me the maximum value and the minimum value within that rating. Everyone good? Have I gone too fast? And left us, so I don't know if she lost connection or did she say she needed to drop? Oh, okay. She'll get her sign. Okay, that's cool. All right. So these are the queries that you need to know for this week. And actually, that's a lie. This is stuff you need to know. This will take you through weeks 2, 4, 6, and 7. I'm giving you this stuff early, so you can start playing with it now. Okay? Does everyone understand the code that I presented to you tonight? Excellent. All right, so now, for the last 15 minutes, we're going to talk about the assignment about reverse engineering a website. Okay, so let me bring this up. Let me move this down here. Okay, let me go to a website. Let me go to cool stuff meetings. Okay, so there is no essay this week. There is just the there is just the, I'm trying to get something here that I want to see. Shop online. Okay. Coolstuffing.com. Okay. And Magic the Gather. Oh, kind of, let's do it. Let's do it. Okay. Okay. So all I want you to do is find a website you're familiar with that you think has a database backend and tell me what you think it looks like. I don't need to see drawings. I don't need to see schematics. I don't need to see an ERD. I just need you talking to me, telling me what you think this database looks like. So it'd be something like this. Hi, my name is Don. I'm in ITM220, and I'm going to reverse engineer this website. I'm going to reverse engineer this website. It's called Cool Stuff Inc. It is a place where people can buy collectible card games and individual cards. So looking at the database, I think there are a number of tables we're dealing with here. Obviously, we're going to have a table for games because I've got all these games across. I've got Magic, Pokemon, Lorcana, so there'll be a table for games. And then here I have versions of that game. So there's probably a table for game versions. And there's probably gonna be a table between the two of them. So if I have a table with games, I'll have an entry for Lorcana, and then for a table of not revisions I'm looking for. Let's call it versions. Versions, Rise of the Floodborn. So I'd have that. I'd have a table of games with Lorcana here. I'd have a table with revisions with Rise of Floodborn here, and I'd have a table between them because I don't know if like there's going to be like if Yu-Gi-Oh is going to have something called Rise of the Floodborn or something else in the first chapter. So I need to have a table between them to match them up. So I have a table for games, a table for versions, and then a table called game versions. Obviously they sell individual cards as well. So I'll need to have a table for individual cards, and then I'm going to need a table that describes each card. So whatever the different types are. So I might have like card name, I might have card and then card type and then like card function and a bunch of others that all kind of lead into one. Because if it was a card and it had a function, like let's look at this card here. So this card is a character is called a beast and the color is steel. So obviously for Lorcana, I'll have a table called card, and then I'll have a table called character, a table called color, a table called card number. And then I'd have all this tied into there. Card text, things like that. And the reason I would have that is because every card will have color, obviously, and every card will have character. And there might be more than one table that's got beast or steel or whatever. But when I want to make sure that there's never a question on what entry will be there. So I'm going to have a table that forces people to use one of my choices to describe this card rather than have them type something out and misspell steel and embarrass themselves. That card's only 49 cents for stupid. That's not bad. And that's it. Thank you very much for your time. I appreciate it. See you later. So that's all I want. That's all I need to see. I just need to see y'all look at a table, look at a front end application, and kind of like work through how the back end works. I don't expect anyone to understand how to design this database. And if you can do that, you probably don't need me because you'll understand this well enough. To anything I say, you're probably going to understand. So if you're doing this and you're like, I can do this at a problem, just finish off the class. You'll be good in 2 weeks. You're awesome. If you have any questions, I can help you. But just kind of talk through with me what you think this database should be. And again, the reason why this has to be on video is because this preempts the need for Precipio. Precipio? Or whatever it's called. The thing that makes us makes you guys take a test with someone watching you. All right. This completes everything I needed to say tonight. I now have 10 minutes left for questions. If not, we will get 10 minutes back to our lives. 9 minutes back. Any questions, comments, thoughts, conversations on anything?
Not really. I think that's kind of it.
So you talked about how we didn't really need to read the chapter. It's more like a reference.
Yep.
What about this week where it's like a 30+ page PDF, the data model? Is that more of a reference, or do you want
Yeah,
us to read
just
that?
leaf through it. Yeah. No.
Okay.
Did you guys ever take the class where it taught you to take the SAT where you read the question, then you go back to the text to find the answer?
Yeah.
Yeah.
Yep, same thing.
Okie dokie.
You know, and my thoughts on this may differ from other people, but when I look at large technical documents, they're not meant to be read, they're meant to be referenced. Because in your career, that's exactly what you're going to do. I've been doing this 20 23, 24 years. I don't read technical books anymore. I just reference them. I'll just pull up if I need to find something. I'll look it up in the chapter and find what I need. And honestly, 99% of the people now just put the question into Google or ChatGPT and get the answer.
Yeah.
So yeah.
Cool. All right. That's all I had.
All right. Well then, friends, thank you for coming by. If you have any questions, text me during the week. I'm here to answer. I will answer text faster. If not, I will talk to you guys next week.
All right,
Of course.
see ya.
Thank you.
Bye.
Bye-bye.